Senior Data Engineer at Grab, and today I'm going to talk a bit about data engineering and its various aspects. Basically, how it works, how is it an important field for data-driven organizations to make key decisions. I'll try my best to give you an overall view of the different things that a data engineer has to handle during their day-to-day work. How the data is processed, how is it stored, how is it accessed at scale, and what even is considered big data if you have come across that term. Also we'll talk about how is the data managed at scale and how do we make sure that the data that we're using is reliable. We'll also discuss about roles and responsibilities of a data engineer, what skills a data engineer needs, as you guys might be interested in it. So today, as of today, data scientists and analysts are very busy with lots of data that is being generated daily to make more of the ever-growing information and data that we have. And they also provide us with methods to draw insights from that data. But interpreting and understanding the data is just like the final stage of a very long journey, as the information goes from its raw format to fancy analytical dashboards that these analysts and data scientists guys use to drive the decision-making process. So maybe just to give an example, right? If you are searching for the definition of plethora on Google, so Google is probably collecting that data and it's probably learning that you have the knowledge gap. So basically processing this data systematically requires a dedicated ecosystem. It requires a set of technologies that form a specific environment where data is obtained, stored, processed, and queried. So along with data scientists who create these algorithms, data analysts who build those fancy dashboards, there are data engineers, the architects of data platform. So yeah, I hope this meme makes sense. Talking about how data engineering works. So getting an overall sense of it, right? It sounds like the sole purpose of data engineering is to take the data from the source and save it to make it available for analysis and data science. It sounds really simple, but is it? So just to take an example, if let's say you book a Grab ride, the data engineer will save that information in a database, and Grab or any other ride-hailing company will run some data science and machine learning magic to show suggestions for drop-off or predict the ETA for your upcoming ride. But is it really that simple to save the ride information in a database? So let's think about an example in a company where there's a scenario that there's a spreadsheet guy who is always doing the boring and mundane task of moving the data from multiple data sources into an Excel spreadsheet, allowing analysts to draw metrics and insights from that data. So could we say that spreadsheet guy is a data engineer? Yes, but is it so simple though? I would say even too much data is also never enough for analytics. So the amount of data keeps on growing every month. There are new data sources to track. There are new fields to track. And the data analysts might have to revisit the same metrics over and over again, every month to track the dynamics. So this setup is kind of very much dependent on the spreadsheet beast. So it's very 90s. So if we say that the company hires a software engineer to automate the job of the spreadsheet guy, would that be it? So yeah, first of all, there's a famous quote by Carla Geyser that if a human operator needs to touch your system during normal operations, you have a bug. So basically, during normal operations, everything should be automated as much as possible. So we realize this need of automation to collect the relevant fields from different data sources and dumping them into storage to avoid like burning out the spreadsheet guy. So what is the process for automating these things? We need 3 steps in order to like have the data in our storage. We need to extract, we need to set up an interface to access data from different sources. Uh, we need to transform the data, like remove any errors, transform the formats, map same type of records and try to validate if the data is okay, and then load it into a database. So that's what an ETL pipeline is called. So this process must also be repeated every month, week, day, or whatever schedule we define. So like for which a data engineer has to write scripts. Okay. So given that we have this data, assuming that we have this data somewhere stored, how do we access this data? How will the analytics team make use of this data? They will use BI tools, basically business intelligence tools, to access this data. So BI tools are generally like UI user interface where like the analyst can connect with different data sources and then try to build dashboards like in visual forms like pie charts, horizontal and vertical graphs or hotspot graphs. Uh, Usually BI tools come integrated with popular databases out of the box. So yeah, as said, analysts will try to analyze or iterate over their metrics, try to improve them and share them with uh, like other stakeholders and try to draw insights from that data that is being populated every month, week, or day. So it looks like we are in good shape. The organization certainly has so much convenient access to data insights. They can use the data to make decisions, and it's becoming like a new culture at the company. Each team is using insights for making key decisions, and their actions are becoming slowly more meaningful. They are now able to see the impact of their changes and like how it changes the way the company works. Maybe like marketing team can use it to track the user activities from their first visit to conversion to a paid subscription to know exactly which user group to target to have more subscriptions. Product teams uses it to understand the customer behavior and their interactions with the software to improve the user experience. Management teams can check the high level key performance indicators to determine how the company is doing, what to improve and how to grow the company. So it feels like suddenly the company has put on glasses after years of blurriness. Yep. So it's all going well until like suddenly the visual dashboards start taking minutes to load. Some SQL queries are getting lost and the current pipeline is not a viable option anymore. This happens because the current setup that was done was using a standard transactional database like MySQL. So standard transactional databases are designed to run operations of an app and are very resilient, but they aren't optimized for complex analytical queries, which usually involves like joining and unioning of data from different sources. Um, so at this point, the software engineer, so whatever automation the engineer did, uh, the software engineer has to turn to become a data engineer and build a data warehouse for the company. So now what's a data warehouse? Data warehouse is a new place to keep the data instead of like a standard database. It's a repository where all the data from different sources is consolidated. So in order to centralize the data, it requires structuring, which is like we define the data into different tables and then define the relationship between these different tables by the means of schema. So basically data warehouses are specifically very much optimized for running complex analytical queries to build those dashboards, as opposed to like regular transactional queries in a standard database. So basically data warehouse queries are built for dealing with more data rather than like individual transactional queries. So yeah, the data must be structured in a meaningful way to serve the analytics team. So it will definitely take a few iterations and interviews with different teams to come up with the best data warehouse design. Yeah, so if let's say the data engineer is able to introduce the data warehouse, we can say that the data pipeline now looks complete and well-rounded. Data is getting generated at sources and then automatically being pulled by ETL scripts, transformed and validated on the way, and finally populates the tables inside the warehouse. Now the team with access to the BI tools, the analyst, can interact with the data in the data warehouse and get insights. Great. So does that mean data engineer can just focus on improvements and can procrastinate a little? But let's say there's a PM, product manager, who comes along and asks the data scientist, like, can we predict the rides for number of rides for quarter 3? Um, So talking about data science, right? The job of a data scientist is to find hidden insights in the data and make predictive models to forecast the future. And for that, data warehouse is not enough. Data warehouse is structured, as I mentioned, right? For data warehousing, analysts might have to interview and like iterate to build the best data warehouse design. So it's mostly structured around reporting on the metrics that are defined by in advance by the analyst. So the analytics pipeline only process the data selectively based on what the team thought to make sense of at that moment. But for data science, their tasks and needs are a bit more sophisticated. They like if a data scientist has to answer this question, they would never usually make full promises. They would say like, this really depends on the uh, type of data or quality of data that we have. So for this now, data engineer has suddenly more work to do. They have to make sure that more data is available for the data scientists rather than just the data warehouse. So talking about that, let's talk about data lake. So we could also say that data engineer can just ask the data scientist what they need and can just design a custom ETL pipeline to deliver the data to them and then call it a day. But that is not very scalable, as we don't know, as even data scientists might not know what data they might need at that point, right? This is only after iterating a certain number of times they will know that, okay, they are missing some kind of data. So another key concept in data engineering is like data lake. So which is the complete opposite of data warehouse. So it's a storage where we keep the data in its raw form. So without pre-processing it and imposing any defined schema. This gives data scientists the power to transform the raw data as they want into something useful to explore different horizons and build machine learning models. So as you might have noticed, the process has now changed into ELT instead of ETL. So now it's extract, load, and transform. So we are extracting from the source, loading into the data lake, and then the data scientists, they will define the process, they will define how to process the data to make it useful. So now the job of data engineer is to provide a constant supply of new information into the lake. So they have to continuously ingest the data from different sources into the lake. So data lakes are like artifacts of the big data era. They have so much diverse and unstructured information that capturing and analyzing it becomes a challenge in itself. So talking about big data, yeah, basically big data is something that is characterized by 4 V's. So it's basically volume, variety, veracity, velocity. So talking about volume, right? If we just put things into like if we just put things into retrospect, today every single minute we create the same amount of data that was created from the beginning of time until the year 2000. So now we are talking in terabytes and petabytes to discuss the size of the data. And the quantity of data is like certainly an important aspect of making it classified as big data. So volume is for sure one of the V's. The other thing is variety. So when we say big data, right, it can be structured, it can be unstructured or like aligned with some schema. So it's not just only like textual data. It can be anything like images, videos, voice files, or anything that doesn't fit into the framework of like say a spreadsheet. Um, Unstructured data usually isn't bounded by any rules. They don't have any schema. So this variety has like put the big in the big data. So other thing is veracity. So veracity defines that data must be trusted and it requires quality control. Is the data accurate and high quality? When talking about big data that comes from a variety of sources, it's important to understand the chain of custody, like from where the data came, what is the metadata about the data, like how is it getting generated, how frequently is it getting a refresh. So we'll talk about like metadata and how do we store the metadata later on. But just to give the context and also the context when the data was collected to be able to get insights from it. So the higher the quality of the data, the higher it equates to the importance of that data to analyze and contribute towards meaningful results for the organization. So another B is like velocity. So we can relate that big data is getting generated constantly in real time. So whenever you check your social media feeds or react to a post on Facebook, Instagram, or Twitter, or even like make a credit card purchase, these acts that you do will create data that needs to be processed instantaneously. Uh, just compound these activities by all the people in the world doing the same and more, and you can start to see how velocity is a key attribute, right? Apart from this, there's actually another fifth V, uh, which is like how can we turn the data into value? So in fact, organizations that have not created a data strategy to yield insights and to drive data-driven decision making are would usually fall behind their competitors. So big data that's analyzed effectively can provide important understanding of customers and their behaviors and desires, how to optimize their business processes and operations and to improve a nearly endless amount of applications. Whether you use data to create a new product or service or to understand a way to how to cut the costs, it is incredibly important that big data creates value. Without value, big data, even though you might have lots of data, but it might not contribute to anything that is valuable for the organization. So does that mean is ETL and ELT enough? We have talked about ETL, whereby we store the data into a data warehouse. We have talked about ELT, where we store the data into a data lake. But is that enough? As I just mentioned about like velocity aspect of big data, talking about like whenever you make certain transactions, there are systems that are processing thousands of transactions simultaneously, and they must run fraud detection on them, right? Or like uh, streaming services like Netflix, Spotify, they create millions of records every second. So being able to process big data means approaching the pipeline in a slightly different manner. Uh, ETL or ELT is only processing batches of data, like it's in a fixed schedule every month, every week, every day, or even every hour. But it will only process the batch of data that comes in that hour, right? But if the data is coming more like in a streaming way, that it's coming every second and we need to analyze it every second in real time, then we have to talk about something like data streaming. So to explain data streaming, right? Uh, so data streaming uses a way of communication called PubSub, publish and subscribe, as opposed to the way how most of the web communication works over APIs. So basically in API, communication, the system will send a request, system or the user will send a request, and they will wait until the data provider comes back with the response. So it's a synchronous communication. If you want to relate, you can relate it to a phone call. So the person on the other side has to finish their thoughts before you get a chance to speak. So basically, this can get pretty slow if the source is generating thousands of records and you have multiple sources and multiple consumers. So if we talk about asynchronous communication on the other hand, like the PubSub enables it by between multiple systems that generate a lot of data simultaneously. Basically how it achieves that is by decoupling the data sources from data consumers. Data is divided into different topics and data consumers subscribe to these topics. Whenever a new data event is generated, it is published inside that topic, allowing subscriber to consume this data at their own pace. So for example, if you're using Twitter, so Twitter or Facebook, uh, like posts gets added to your feed independently and you can consume that information at your own pace. You can stop reading for a while and then come back and start scrolling again. Basically, you are the one who's controlling the flow of information that you're receiving, and multiple sources, or rather multiple Facebook or Twitter accounts, are supporting you with the data asynchronously. So one of the most popular PubSub technology is Kafka, which is used extensively in data engineering. So yeah, basically this way systems don't have to wait for each other and they can send synchronous, they can send messages and can deal with thousands of events generated every second. Okay, so now coming to the storage, we talked about storage, right? But we can't possibly think of storing petabytes of data that are generated every second on like maybe on some disk, maybe on some laptop, or even like on a single server. So it might require like several servers at the same time, and even like thousands of them. So we usually call a group of such servers a cluster. So there's a technology for this distributed storage, and it's called Hadoop, and it's very famous in the big data world. So Hadoop, for a fun fact, is named after a toy elephant of the 2-year-old son of Doug Cutting, who is the creator of Hadoop. So basically, Hadoop is a framework that allows for storing data in clusters, and it has the following key features. That one thing is it's very scalable. So you can keep on adding more and more servers to your cluster as your data gargantua keeps growing. Other thing is it has much redundancy for securing information. So redundancy is important because if let's say some of the servers in the cluster like burst into flames, then the data won't get lost because it's replicated into multiple servers. Yeah. So having said that, since we have the data stored in a distributed way in a Hadoop cluster, we also need specific tools in order to be able to like process this data. So to make the stack feel complete, we can mention Spark. It's one of the most popular big data processing frameworks. So to talk about Spark a bit, like it's a data processing framework that can quickly perform processing tasks on very large data sets and can also like distribute the data processing tasks across multiple computers, either on its own or in tandem with other distributed computing tools. Basically, these two qualities are key to the world of big data and machine learning, which require the use of massive computing power to crunch through this large data stores. Spark also takes some of the programming burdens of the developers. Like they give an easy to use API that abstracts away much of the grunt work of distributed computing and big data processing. So writing Spark is way easier than writing map reduce jobs. So map reduce is also one of the old technologies that is still in use, but like it requires a lot of code for doing very simple things. But Spark takes that burden away. So yeah, Spark started at UC Berkeley in 2019, and now it's like one of the key big data processing frameworks. It's and with a lot of contributors contributing to make it even better. Spark can be deployed in a variety of ways. Like it can work with different binaries from Java, Scala, Python, and R, and it also supports SQL because SQL is convenient, and it also has support for like machine learning and graph processing. Spark is being used by probably all of the major tech giants, banks, telecommunication companies, game companies, governments. So just to emphasize how important Spark is in the big data processing world. Can we say this is how an advanced data pipeline would look like? So basically, we have Kafka, PubSub streaming, which is asynchronously pulling the data, and then there is Spark to process that data either via ELT or ETL, depending upon our use case, whether we want data lake or data warehouse. And then there's some custom ETL as well. And then on the other side, there are users like data analysts, data scientists who are using BI tools to build their dashboards and doing some machine learning magic. Yeah, so basically, this could be one of the pipelines, but this isn't just like the end of the story. There are many more other things like how the data can be consumed by other systems and generate predictions and even new data. So whenever we are dealing with such huge data, right, we have to also find a way on how to manage the data, right? So talking about how to manage the data. So basically it's called data governance. So let's say there's something new happening at the company. There's a new vertical and a new analyst or data scientist joins the company, and they are given a task to build a new dashboard or prediction system for a recently introduced vertical. So with lots and lots of data available in the data lake and data warehouse, there are many questions that they might have, like what each data set means, what data sets I need, which raw data sources do they come from, how often is the data refreshed, what are the attributes and size of the data, do I even have permission to access this data, is the data even clean and reliable? So to answer these questions, there are some key aspects of data engineering that we have to take in to account. So there is something called data catalog. So with more data than ever before, being able to find the right data has become harder. So basically data catalog is something that will give you like a single overarching view and deeper visibility into all of your data to remove any data silos. So for an example, right, whenever you go to a library, you need to find a book. You use their catalog to discover whether the book is there, which edition is it, where it's located, a description, everything you need, so that you can decide whether you want it, and if you do, how to go and find it. So that's something that like many data warehouses and databases and object stores offer today in terms of data cataloging. But now try to think about like the same analogy, but expand it to cover every library in every country. Imagine that you suddenly have one interface and you can find every single library in the country that has a copy of the book that you're interested in. And you can find all the details you'd ever want on each one of these books. So the scale of data catalog is similar. So as I talked about, finding the right data has become harder. There are many challenges. Some of them are like wasted time and effort on finding and accessing data lakes turning into data swarms, no common business vocabulary. There could be like someone analysts mentioning some like particular business specific lingos which has no vocabulary and the other person might not understand it well. Um, how hard to understand like structure of the data, difficult to assess the quality and trustworthiness of the data, like no way to capture any missing knowledge, difficult to reuse knowledge, and even like manual and ad hoc data preparation efforts that someone might need to do if a data catalog is not present. So if on the other hand, if let's say we use the data catalog in the right way, it can contribute to a lot of things. Like you could possibly cut costs, you could save costs. There could be operational efficiency because you can easily identify the cause of any data issue. Uh, you would definitely have competitive advantages, better customer experience, and maybe even fraud and risk advantage. Yeah, so just to talk about how data catalog works, right? It's an inventory of all the data assets in the organization. It uses metadata to help organization manage their data. So basically, which will help them to support like things like data discovery and governance, which includes things like what is the shape and characteristics of data, how are the values distributed, like what's the min max, and like maybe yeah, even frequency, statistical information basically, and also something as important as PII, which is personally identifiable information or personal health information. Yeah, so some key features of catalogs are uh, they are like they have the search and discovery feature. They can allow users to quickly find their data sets. They can allow users to browse the metadata based on technical hierarchy of data sets, like how the data sets are dependent on other data sets. Um, they can also enable users to enter like technical information, user defined tags, or business terms that are specific to those data sets. Other feature of a data catalog is like it can harvest metadata from various sources. Imagine like you have multiple data sources. So a data catalog should not be the bottleneck in the way like it cannot connect two different sources to collect that metadata. Yeah, so it should also allow for subject matter experts who know about like how the data set is being generated and what it means to contribute to the like business knowledge by just providing tags in the catalog and like user defined annotations, classification, even ratings, like if it's a bad or a good data set. Other thing is lineage tracking, like again for issue date, if there is any data issue, you can go back from where the issue came in. Yeah, I think, yeah, that's a yeah overview of data catalog. So, but we mentioned about metadata, but what is metadata? So metadata, to put it simply, is data about data. So there are three kinds of metadata. There is technical metadata, there's business metadata, and there's operational metadata. So schemas, tables, columns, file names, all these kind of things that are documented in the source system is considered technical metadata. Business metadata is like any business knowledge that users have about the assets in the organization. This might include like business descriptions, comments, like what, for example, like if there is a food delivery happening, so there's a data set about which food order got assigned to which driver and how much was the cost, like how much was the order worth. So all this, and there could be like business specific things as well. So all those things can be like classified as business data metadata. And then operational metadata is something like how often the data is being refreshed, which ETL job created it, and how many users are trying to access. So how does it matter, right? like if many people are using it, it's probably being considered a good data set, like as in like it's really useful to use. And if we know how frequently it's being refreshed, then that means like we can build our pipelines in a way that we know, okay, when we are serving the stale data, or whenever like we are having, basically we can be in control of how fresh data are we serving, right? So collecting metadata from these various sources and making it available in a data catalog is also one of the key functions as a data engineer. That's why we are talking about this. So metadata was something that was used earlier for auditing, lineage, and reporting. Today, like technological innovations like serverless processing or graph processing has pushed the boundaries to make it like make things possible that weren't possible at the scale before. So it can be used to augment data management. Like it can enable users to have, it can enable data engineering teams to have self-service data preparation tools, whereby like the having like role and data content-based access control. So who can access what data, and also like automated data onboarding. So bringing down the pressure on data engineers to keep on maintaining those things and focus on other better things. Yeah, I think that's what the metadata enables. Okay, so with the use of big data, right? There are more rules and regulations than ever before, with GDPR being just one of them, if you're aware. So GDPR is General Data Protection Regulation. So how do we make sure that data is assessed in a secure way and compliant with the privacy policies? So if you've heard about like data breaches, you might know that it is a big thing. It might cause like losses to companies of millions of dollars, and also the loss of trust from its customer and users if and whenever there's a data breach. So basically, we have to make sure that our data lake warehouses, even though they are hosting different kind of data from various sources, we need to make sure that they are accessible in a secure way. And also like from the sensitive data kind of thing, like maybe credit card information and your address or something, all those needs to be protected as well. Uh, so so like sensitive data, specifically like user address, phone number or credit card number, banking details, passwords. So these like these needs to be protected. So to secure it, someone can have like various strategies, like keeping out unauthorized users. So we can have very good firewalls. We could have like very good user authentication process, and like we could even give training to our users to make sure like the data access is secure. So all these things, right? Data engineering also entails building these mechanisms to ensure secure data access through the data lake and data warehouse, hiding sensitive information about users, filtering subset of the data to only give the relevant information based on user attributes. Like maybe someone in Philippines might not or should not be able to access data in Singapore. So that is just an example. And retaining the data only up to a period and then archiving the old data. Like for GDPR, right? Um, if someone wants to delete their data, then ideally the company should not be storing it, even in their big data like data lakes or data warehouse. So there should be mechanisms to ensure that when some user or customer wants to get rid of their data and being in the company, so that needs to be there. So of course, all of this data security regimes, data engineers, even though they build the tools, they need collaboration with information security and data governance officers who define the policies around this, but the engineering work or building the mechanisms is being done by a data engineer. Okay, so far so good. I think like the new analyst or data scientist that we talked about, right? They have figured out the access. They know the sources of the data and what it means, how often it's refreshed from the data catalog, but they still don't know if the data is reliable, right? So basically, data quality is a measure of the scope of data for the required purpose. It shows the reliability of a given data set. Yeah, if we have to talk about why is it important, right? Basically, if you have low quality data, it impacts the business process directly because you fall short on vital information which you need in making decisions for your business tasks. So data quality is significant because without high quality data, you can't understand or remain in contact with your customers. So if you don't know your customers' behavior, then you are probably falling behind of your competitors. High quality data is likewise a lot simpler to use than low quality data. Imagine like you have data, but there's a lot of like incomplete information and you would have to spend a lot of energy to fixing that information to make it usable, right? So if it's already high quality, then you can just use it, start making use of that. Yeah, data quality also helps keep your company's various departments on a single page so that they can work together more effectively. Yeah, so some of the best practices to improve the quality of the data are as follows. Basically, we should try to capture all aspects and attributes of data quality. Uh, so talking about the attributes of data quality, there's consistency, accuracy, orderliness, auditability, and completeness. So consistency like refers to to having no contradiction in finding the data, no matter where we find the data in the database. So the number of metrics should be consistent. Accuracy defines that the information that contains the data should correspond to reality. It should not be like something random. Orderliness defines that the data should be in a required structure and format. Like it should follow a proper arrangement order. Imagine like you have a time series database and the date is not formatted to a standard, like it's always randomly formatted. Auditability. So basically this makes sure that data is easily accessible where it is stored in the database and someone can easily trace the changes that are done. Completeness is like data probably has like different number of elements. So these interdependent elements that we have should have complete information about them so that the data can be interpreted correctly. So that's about the attributes of data quality. So other best practices are like we should automate the data quality metric collection at source, like the raw data ingestion itself. And we should build tools and mechanisms to integrate the data quality at each step of processing. And one other important thing is like we should preserve the master data, the raw data, and like the metadata carefully so that at any point in time, if we want to compare the data and if we want to control different versions of the data, that should be doable. And we should also like build dashboards. So earlier we were building dashboards around data, but now we should also build dashboards around the data quality and monitor them so that we know that whatever data the company is relying on is high quality data. So this is also a key aspect of data engineering to like build tools and mechanisms to automate the collection, monitoring, and projection of data quality metrics. Okay, I think I have covered like various aspects of data engineering for now. I think we can have a small break. And after this, we can talk about like what are the, you might be interested to know like what are the roles and responsibilities of a data engineer, what skills do they need to like possess, and maybe I'll also share like a brief overview of data engineering, how it's done at Grab. Yeah, so let's connect after the break.
So thank you, Raj. I think we'll have a 5 minutes break from now. So we will all come back at 7:45. Thank you. Okay, hello everyone, welcome back. Okay, we'll continue with the rest of the workshop. Okay.
Okay. Yeah, so hi everyone. Let's continue. Yeah. So having talked about different aspects where data engineers contribute, right? So the question arises like, what is the role of a data engineer? So the role of a data engineer is as versatile as the project requires them to be. So it will correlate with the overall complexity of the data platform, as they are called the architects of the data platform. So if there are more advanced technologies like machine learning or artificial intelligence are involved, the more complex and resource heavy data platforms become, and then accordingly more data engineering is required. So this figure illustrates like depending upon how the data science hierarchy of needs grow and how accordingly data engineers like the work scope also increases, and it's compared to like oil industry infrastructure. If you see that this is a very simple pipeline and then complicated and then something even more complicated to the point it looks like transformers. So yeah, so talking about like responsibilities of a data engineer, right? Data engineer, it can correspond to the whole system at once or each of its parts individually. So it can be a general role, warehouse centric or pipeline centric. So a general role data engineer is like uh, responsible for every step of the data flow. So it could start from configuring data sources to integrating analytical tools. All these systems would be architected, built, and managed by a general role data engineer. From like basically all the way from data ingestion from different sources to transforming and putting them into data warehouses, or just putting them into data lake and then integrating it with different BI tools. Uh, so warehouse centric roles are like data engineers who are working to architect a data warehouse specifically. So they can consider like they might cover different type of storages like NoSQL, SQL, different tools to work with the big data like Hadoop, Kafka, and integration tools to connect different sources or databases to the warehouse. And then there is pipeline centric data engineers would take care of like data integration tools that connect sources to a data warehouse. So their job is that like their tools can just load information from one place to another or carry like more specific tasks. For example, like there could be data staging areas where data arrives prior to any transformation. So managing this layer of the ecosystem would be the focus of a pipeline centric data engineer. Uh, yeah. So regardless of the focus on a specific part of a system, data engineers have similar responsibilities. This is like mostly a technical position that combines knowledge and skills from computer science, engineering, and knowledge of databases. To talk about some of the responsibilities, right? As I mentioned, that they are the architects of the data platform. They need to design the architecture, uh, like which tools to use, which uh, technologies to use to build the products, and then how to integrate them, what storage layer to use or what compute layer to use, and how to make it available for data access. Yeah, they are also like as they are developers in the first place, they also use their programming skills to develop the data related instruments or tools and customize and manage like integration tools, databases, warehouses, and analytical systems. So during the development phase, data engineers would also usually test the reliability and performance of each part of the system. So they are also like kind of doing data pipeline maintenance and testing to make sure the data pipeline keeps running. Yeah, in some cases, whenever like machine learning models are designed by data scientists, data engineers are responsible for deploying those models into production environments. So this entails like providing the model with the data stored in a warehouse or coming directly from sources, configuring data attributes, managing the compute resources, setting up monitoring tools so that like the data scientists can see how much resources are being taken and monitor their pipelines. They are also responsible, as we talked about data cataloging, right? They're also responsible about managing the data and the metadata. So the data can be stored in a warehouse, either in a structured or unstructured way. So additional storage may contain like metadata exploratory data. A data engineer is in charge of managing the data stored and structuring it properly in like some DBMS so that it can be surfaced by a UI in the data catalog. In some cases, like we have to provide data access tools as well so that the data scientists or analysts can pull the data right from the storage. If like an organization requires business intelligence for analysts and other non-technical users, data engineers are responsible for setting up those tools to view the data, generate reports, and create visuals. Usually it's like a cluster, a compute cluster, which can directly fetch the storage and then process the data and like uh, give it to the user. And the users would just write SQL to get that data. Yeah, that's just an example. And then they are also responsible for monitoring the overall performance and stability of the system. Because as long as the data pipelines are there, they need to be cleaned from time to time. The automated parts should also be monitored and modified, since like there are usually data model or requirements changing. So they also track the pipeline stability in a way. So talking about skills, right? What skills a data engineer should have? The skill set, we could say, would vary, as there is a wide range of things a data engineer can do. But generally, their activities can be sorted into like three areas: engineering skills, data science, and data warehousing skills. So for engineering skills, most tools and systems that we use in big data are written in Java, like Hadoop, Apache Hive, and Scala. For Scala, there's Spark and Kafka. So, and there's also Python and R being used because they are popular due to their syntactical clarity and ease of use. There's also use of C# and Golang, like for high performant things, especially for training and implementing ML models. So for data engineers, it would be common like to have to know like at least one of these languages and have some software architecture background. For data related expertise, data engineers could closely work with data scientists. So they need to have strong understanding of data modeling, algorithms, and like data transformation techniques. Um, as the data engineers, as we know that data engineers are in charge of building ETL pipelines, designing the storage, and even analytical tools. So experience with them like building ETL and BI tools is also a must. So there might be more specific expertise required to take in big data projects that utilize dedicated instruments like Kafka or Hadoop. If let's say the project is connected with machine learning and AI, then data engineers are also expected to have experience with ML libraries and frameworks like TensorFlow, PyTorch, MLPack, And I think like, as we also mentioned about Spark, so Spark is the tool that is required for processing the data. So having familiarity with Spark is also something uh, that's something data engineers should have. So yeah, to sum it up, for the data related expertise, they should have strong understanding of data science concepts. They should have expertise in data analysis. They should have hands-on experience with ETL tools like Spark, BI tools knowledge, big data technologies like Hadoop and Kafka, and then ML frameworks and libraries like TensorFlow, PyTorch, ML Pack. Yeah, and for the last thing, in most cases, data engineers use specific tools to design and build data storages. So this storage can be applied to store structured, unstructured data for analysis or plug into a dedicated analytical interface. In most cases, these are relational databases. So SQL is the main thing every data engineer should know for like DB and querying. There are other instruments also like Talend, Informatica, and Redshift, which are popular solutions to create large distributed data storages based on NoSQL. Um, so there are also cloud warehouses or yeah, managed data platforms, which are offered by various like vendors. So having knowledge of that would also yeah, would also be a skill that a data engineer like it's good to have as a data engineer. So for database warehouses, like maybe to sum it up, they should have, it's good to have knowledge about SQL, NoSQL, Amazon Redshift, Oracle, Informatica, Apache Hive. So yeah, basically nowadays with the growing adoptance of cloud technologies like AWS, Azure, GCP, data engineers also have to be proficient in navigating through these various cloud technologies and how they connect with each other. Since data engineers are like architects of the data platform, they might also need to work on provisioning and maintaining that infrastructure, which might need hands-on experience with DevOps technologies like um, Kubernetes, Docker, CI/CD, Helm, Terraform. So yeah, basically, if we have to sum, there are like a lot of technologies that data engineers are involved with. So I think depending upon like which of these skills someone is most experienced at will define like the uh, aspect of data engineering that the data engineer is going to be working on. Like they could be uh, purely related to provisioning or maintaining infrastructure which is related to our big data tools, or they could be purely related to building pipelines for data scientists so that they can access the data whatever they need. So it really depends on the skills that you have, but as data engineering covers a lot of surface, any of these skills will help you like to become a data engineer. Yeah. So to give an overview of data engineering at Grab, right? So this is how it looks like. This is yeah, brief overview. So we have the like Grab apps. Like right now, it's just like a single app, super app, which has certain sub components like transport, food, uh, shuttle, Grab Pay, all those things. So these mobile apps interact with backend services, which are built, which are deployed into the cloud, and most of them are written using Golang. And these backend services connect with databases like MySQL, ScyllaDB. So events from the mobile apps and like the backend services, as we know, like a lot of users are using Grab, right? So a lot of these events are getting like published into Kafka, which we talked about previously. and then it's being like pulled from Kafka clusters and ingested into our like ingested as raw data into our data lake. So that processing is happening either via Spark for batches and Flink for like real-time data ingestion. So these Spark cluster or Flink clusters are running on Kubernetes. So yeah, Kubernetes is a way to orchestrate the infrastructure. And they are also using Airflow. So Airflow is a tool that allows that enables users to orchestrate their pipelines in a way that they can define what happens after what and then how frequently it happens. And they have a UI. It has a nice UI to see which instances of the execution ran successfully, which failed, and all that. So it's an open source tool. So as you can see that it also interacts with something here called Lighthouse. So Lighthouse is actually one of the internal tools developed by Grab. So it's like for data cataloging and data, like part of the data cataloging things. It stores the data like dependencies, like job dependencies, that when a job is getting completed. So it stores that kind of information so that whatever pipeline is depending on that data set can know that, okay, this data is safe to use. Yeah, and then basically from the data lake, this data is being read again, and then this is doing this is using Kubernetes based clusters running Spark and Flink. So they are doing there's some data transformation happening and then some machine learning happening over top of the like transform data using TensorFlow, Keras frameworks. And again, this data models and data marts are pushed back to the data lake, where it's consumed via query engines like Spark, SQL, and Presto to query the data and for ad hoc use cases or even building like reports and dashboards. So yeah, for visualization and analytics, we have like Holistics, Tableau, Tremio, T3. These are kind of tools that are available, that are made available by different vendors. Yeah, and then basically data gateway is something that is responsible for data security, so that only users with relevant access can access certain data sets. And if they are not authenticated, they won't be able to access the data. So this is also an internal tool. Yeah, and from this visualization and analytics, the analysts would build dashboard and reports, which the executives, the high level management will look at. So if you see that there's something that is at the center of it, it's called Data Hub. So Data Hub. So we have talked about data security, we have talked about ETL, and then we have talked about Kafka, Spark, uh, maybe DevOps stuff as well. Yeah, and this data lake that is represented here is actually cloud storage. It's Amazon S3. So it's also like distributed storage like Hadoop. Yeah, and then we have talked about data cataloging to some extent. We have talked about data security. So Data Hub is something that also solves the other aspects of data cataloging, like what each data set means, what is the quality of that data, and like uh, how frequently is it refreshed, who is the owner of the data, and such things. Yeah, I think, yeah, that's just an overall view of data engineering at Grab. Yeah, I guess if you guys are interested, you can visit grab.careers and then find any suitable positions, internships, whenever you feel ready. So yeah, I think that's all from my side, and now we can take questions.
Thank you so much, Raj. So now we'll be moving on to our Q&A session. Does anyone have a question for Raj? Can for those people online, you can just type in the chat box. Anyone from the Singapore audience? Yes, please.
Yeah, hi. Yeah, so if I, yeah, sorry, go on. Yeah, okay, sure. So if I talk about my journey, right, I did my master's in UK, and one of the modules there was big data, and that's how I really got interested into big data, because I think the first problem that you have to solve as a like a data engineer or someone who's trying to deal with big data is like word count. So you are given lots of files with lots of words, and you have to get the count for each word. So I used MapReduce, and then I was really like liking, and then got introduced to Spark as well, and then I was really liking like how it really matters for different companies. And yeah, I think that's how I really like applied for a data engineering role at Grab, and then I got in as data engineer. And during my journey at Grab, I would say it has been like a very good learning journey. So I have dealt with typical software engineering things like building CI/CD pipelines, making sure that our source code, whatever ETL pipelines we write, are like getting built properly, and then it has integrations with Jira, uh, tools like Jira, etc. And then I have also built ETL pipelines using Spark and Airflow for orchestration, and then there's Apache Hive for managing the metadata. Yeah, and those I was really like uh, getting more into it, like when that data sets, those data sets started getting used by the whole company as centralized data sets uh, for doing any kind of analysis. And then, yeah, I've also done some contributions in terms of like orchestration specific things like Airflow, build some operators or things like uh, where different teams can also rely on those operators. And yeah, of course, we also had to, like I mentioned about like the responsibilities of a data engineer, right? As data engineers, we also have to track our pipelines that we wrote, and we have to make sure that the SLAs are met, service level agreements are met. And if there are any issues, we have to debug them. And then as we grew as a company, right, we started building more and more like products that are self-service rather than data engineering team being the bottleneck and serving all these requests. We try to build tools that could help the user serve themselves. So yeah, I was also responsible for building one such tool with proper access control and approval workflows to manage the metadata about their tables, defining the schemas, and making sure the data is available for querying. And then now more recently, I am like working with the query platform team and like managing the infrastructure for our like querying infrastructure, which is like using this technology called Trino or Presto. Um, so yeah, we are orchestrating the way how the queries are routed to different clusters. We are managing the pool of clusters. We are doing version upgrades. So it has a lot of infrastructure or like DevOps kind of work as well. So I would say like it's something personally like very much of a learning experience for me. I got to work with a lot of different technologies. So it's a really satisfying experience in my experience. Yeah.
Uh, does anyone have any more questions? Anyone, uh, any more questions from Zoom? Okay. Yeah, there's one question for you.
Have you worked on your own personal projects, and if you did, what project helped the most? I would say that like not really own personal project, but yeah, I've taken ownership of projects at Grab, and then I have like did some like projects that I thought that would make sense and would contribute to Grab without it being like a task for me. So Yeah. So one of the project is like, so right now we are having, we are managing the query platform, right? So the users are submitting queries randomly and we are distributing them based on some predefined rules. What we are trying to do, and we are also collecting that data, like which user submitted which query at what time and how much resources it took. So now we are trying to build a, uh, yeah, and now we are trying to build a predictive model, like a machine learning. So I'm also like from data engineering, I'm also getting into machine learning now to predict like how much resources a query would require in the beginning itself, so that like we can route the query more appropriately, so that the query's failure rate goes down, and then we are able to have better user experience. So that is something, yeah, I think um, I hope will help the platform. I hope that answers your question to some extent. I guess there's another question. Is there any particular reason or interest that made you pursue data engineering instead of, say, data science or analytics? Yeah. So to be really honest, I am from a computer science background, and I would say I like creating algorithms and I like to actually build stuff. I think regardless of that, data science and data analytics, interpreting the uh, data is an art of its own, and getting insights from them is like a really important thing for a company. But for me, it was definitely like uh, that, like creative liberty to build something is was something that was really important to me. Um, like having using my programming knowledge and yeah, and using my knowledge about databases, and also the ability to process such big data at scale is what was interesting to me, than to like how to like make sense of that data.
Thank you, Raj. Is there any more question from the online audience?
Yeah. For a fresh grad to become a data engineer? Yeah, I think I would say like as a fresh grad, right? One thing I think as a computer science engineer or any engineer who's interested in programming, whenever you code a piece of algorithm, right, you would always consider the complexity of it, right? You would try to see like how big is the data set that we are running the algorithm on, and how long would it take, right? So if you are really interested into big data, right, you should try to think of breaking that problem into multiple sub problems and then like parallelizing it. So that's how like it's a basic thing of data engineering. And then when you try to parallelize it more, you would need more computing power. That's how you start using GPUs and all that stuff. But if you really want to like get those skills to become a data engineer, I think yeah, you can. I think Spark is the bare minimum thing that you should try. So you can try Spark to write algorithms that can do some kind of like data processing. And yeah, and I think apart from that, it's just normal like programming languages experience like Python, Java, Scala. Yeah, and I think if as a fresh grad you have knowledge about Spark, you can pretty much get insights into how different tools work pretty easily as well. Yeah. Yeah. So is there a high demand for data engineering jobs nowadays? I I would like to say yes. Currently, as the companies are becoming more and more data driven, there are more data analytics and data science use cases. But I think some companies also have data science and analytics guys without a data engineering team who are doing the data engineering work. But as the scope grows, right, that need for data engineering arises. So I think, yeah, uh, if I have to say, like, there are a lot of data engineering, there's a lot of data engineers role these days, and I think it makes sense that it's a job that is meant to stay, as in the future we will have even more data needs. Yeah, there's another one. For someone with no experience in data, what are your tips or advice to enter into the data field, engineering, analyst, scientist? I think the only tip or advice I have is to, like, uh, start relating the things with data, or how data would empower you. If you start thinking about those things, then you would probably want to learn more about how we can process the data, or how we can use data to generate insight, right? So basically taking up projects like where you there are a lot of like website, I'm pretty sure, that would have these projects that you can take up. And like Kaggle is one such data site where you can find data science projects, which would also involve data engineering for sure. And then you can try to understand the problem deeply, and then try to understand how the data will help here, and how to get that data, how to process that data. And then once you figure out the how to's, then you will have to figure out like which technologies to use, and then you will get into the technical implementation. So if you keep on following these steps, right, it will do two things. It will build your interest. Either it will build your interest, or it might not. If it builds your interest, then it's also helping you gain that experience. So I think that's just what I feel about this.
Okay, thank you much for your questions. I think that's the end for the Q&A session. Yeah, and with that, I think we comes to the end of our workshop today. So please follow us on our NTUSS Telegram page. And thank you very much for Raj for hosting this workshop today. Thank you.
Thank you.
Thank you for attending the workshop. Thank you.
Okay.